So who among you here ever played a seesaw? No? Have you ever played a seesaw before? Yeah? Okay. So, what is your purpose of playing that one? Just to enjoy? Okay. To swings back and forth. Right? So, somehow, no? Playing a seesaw with your friend or partner, okay, sometimes it differs about body weight. Alright? You need to control, no, your body weight, okay, just to go along with your friend. So it goes clockwise or counterclockwise as part of the reaction force of the fulcrum. So today, we will talk about forces and moments. When we talk about forces and moments, in other words, we call it as moment of torque. T-O-R-Q-U-E. It's torque. So, let's go deeper. What is it all about? Okay? It is the moment of rotating. Moment of rotation. No? Spinning of something, okay, by clockwise or counterclockwise direction. So for example here, no, I think you guys are quite familiar about spanner, right? So what spanner is? What's the purpose of this? To loosen or tight the grooves of the screw, right? So this one, the spanner helps, no? It is useful for tightening and loosening nuts, no? They help to produce larger turning effect. That is the purpose of spanner. So most likely when it comes to emergency, no? Or somehow repair of something, especially parts of our car, motorcycle, bicycle, or our engines if there is something wrong, no? Or something malfunctioning, right? Spanner is very important and very useful, huh? If you want to adjust something based on some situations that we experience, right? So spanner is very useful too. But let's try to think of this. Why spanner is a good example of turning effect? Remember, turning effect comes into clockwise or counterclockwise direction. So, the indicator there, the longer the spanner, no? If our spanner is long, we also have medium size, small size, or longer size spanner. No? So, the longer the spanner, the greater the turning effect. This turning effect is what we call force. Take note of this. Right? So, this spanner acts. No? It will also affect how long your spanner is. If your spanner is long, you'll have a higher or greater turning effect. No? It might be easier for us, and we can also save time, no? To loosen out or to tighten the grooves of the screw. You understand, guys? Or what we call nuts. No? So therefore, what is the presumption of this force moment of torque. So the turning effect of a force is called moment. I'll repeat. The turning effect of a force is what we call moment. Right? So, forces and moment, or moment is equals to force times perpendicular distance from the point. So a moment of force about the point, force times perpendicular to distance, or MF is equals to F times D. Okay? Because moment of force is directly proportional to the force and the distance. So therefore, that is our formula. We use multiplication for this operation by solving problems. So moments may be described as clockwise or anti-clockwise, and moment of a force is also called torque. I repeat, moments may be described as clockwise. What is a clockwise direction? Have you seen a clock, right? Your narika, your watch. What is the direction? Clockwise. So it's clockwise direction. Okay? So when we talk about clockwise direction, okay, something like this. 1, 2, 3, 4, down to 12. Okay? If we talk about counterclockwise direction, it should be like this. Moving backward. From 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? So that's counterclockwise direction. So, if there is clockwise, there is anti-clockwise or counterclockwise direction. Got it? So that's how the turning effect is all about. So don't forget that the unit of force is Newton. The moment of force is what we call Newton. Right? And aside from this one, forces and moments helps to increase the force applied to undoing the wheel nut, extend the length of the spanner, as you can see here, and this is the wheel nut or wheel nuts. Okay, 1, 2, 3, 4, 5. And this is an example of spanner. This is a tool, important tool. So, we extend the length of the spanner. You can do this by inserting a length of the pipe over the end. So as I've said, it also affects how long the length of your spanner, either short, medium size, or longer size. Okay? So the longer the spanner, the larger or higher turning effect. The shorter the spanner that we're going to use, okay, the shorter the turning effect. So this is the presumption about moment of torque. Now in this example, let's have a look at the few examples of calculating involving moments. Now here. So this is the point of reference, X. Okay? So you may notice about the object here, now in between, the moment about X. So what is the moment of force? The moment of force, the reaction of force in here is going down, clockwise direction. This arrow represents as clockwise direction. So therefore, it reaches to 5 newtons. So this one is the reaction force of an object. That is why this platform will be going down due to the gravity or the mass of an object here that contains 5 newtons. So, what is the distance? 4 meters. And what is that object? It could be bags or any objects. that may contain 5 Newton or maybe 5 kilogram if we will use the simple term. Okay? So again, how to solve problems related to this. Moment force, no? We need to find X in here, okay? Times 5 Newton, which is the force, times 4 meters as distance. Okay? So moment of force is equals to 5 Newton as its weight of an object multiplied by 4 as its mass of an object. I mean distance. No? So the distance here, 5 times 4, that will be 20 Newton meter. So it is in clockwise direction. Do you understand, guys? Okay.